So we're going to look at graphing transformations of exponential functions. So the key concepts. So this is the important information that we need. So if we have our function f of x, we have a, b, x minus h plus k. So we're going to look at the effect of the minus the h, the plus the k, and then we'll have a look at what happens when we have an a value. So h, the h value, you can see is minus h. Okay, so h, this is going to be translating to the left or to the right. Now, because it's minus h, it's going to be the opposite. So, for example, if we have minus 3, it will be 3 units towards the positive, to the right. And if we have a plus 3, it will be 3 units towards the negative x, so it will be 3 units left. So the k value. So the k value, you can see, is positive. So this is going to translate up or down. So if it is plus 3, it will translate 3 units up. And if it's minus 3, it'll be 3 units down. So let's have a look at a couple of examples. Okay, so I'm using a graphing calculator. I'm using Desmos. So I've put in my graph, which is the parent function, y is equal to 2 to the power of x. So our intercept, this is at 0, 1. And if we translate it, so we'll add this graph. So plus 1, you can see that the intercept has moved up to 0, 2. So it's actually moved up one place. So from the parent graph, if I have the equation y is equal to 2x minus 1, so this is our k value, you can see that it's translated down 1 unit and it's gone from 0, 1, and the point is moved onto our 0, 0 for our green value. If I can find it, there we go, to 0, 0, the intercept. If we have a look at the next graph, we can see x minus 2. So our red, so we said with the h value, is 2 units to the right. So we can see our intercept at 0, 1 is now moved across to 2, 1. So it's actually from here. Oh, let's put it in. Okay, so we can see that our point has moved from 0, 1 to 2, 1. So it's been translated, so 2 units to the right. So if you have a look at the next one. So this time we've got y is equal to 2 and it's the power of x plus 2. So this means our graph is moved 2 units to the left, and our intercept, instead of being at 0, 1, is now at, so let's just type that in, minus 2, 1. So if we look at our graph, okay, we can see that this we said is translated. So this has been moved this way. So it's being translated 2 units to the left. So this is for when we have y is equal to 2x plus 2. Now we're going to have a look at the domain and the range. So on our graphs, the domain is the x values. So this is always the x values with exponential graphs. So this is going to be for all our values. So it's going to be all real numbers. And if we look at the range, so the range is going to be the y values. So what do we know about the y values? Well, it's going to be any value that's greater than 0. So y is greater than 0. Okay, so we're going to have a look at the range and the domain. So we're going to look at, we've got the red graph, which is 2 to the power of x. And then we said that this one here, this is our translation, 1 unit. So this is 1 unit up. So when we look at the domain, so the domain for this graph, this is the x values. So this hasn't changed, it's from negative infinity to positive infinity. Graphs increasing, exponential growth. This is all real numbers. Now when we look at the y values, this is the range. So y values, what do we notice? Well, this time our new asymptote, if we were to draw a new asymptote, so let's just take this off a second. So we've got the asymptote that y is equal to 1. So this is moved from y equals 0 to y equals 1. So it means that we will not have any values that actually reach 1. They're going to be greater than. So be any value that's greater than 1. Okay, so if we look at this graph, this time we've got our graph, which is 2x and it's minus 1. So it's actually moved down. So our asymptote this time is on the line y is equal to minus 1, which means that it's not going to actually reach minus 1, but it will be close. So our domain, all the x values. So the x values. So this will be all real numbers. Okay, and I'm also going to write it like this, negative infinity to positive infinity. Okay, so the round brackets means that it doesn't actually equal, because it doesn't actually reach that, but the range, so this time the range is all numbers greater than minus 1. So the y values. So this is going to be the set of numbers where y is greater than minus 1. Okay, so we're going to have a look at what happens when we have a value. So we're going to be looking, so we have, so this is f of x, okay, when we have an a times b, okay, our b is x, and this minus h. So in this case, our question, so we're going to look at this graph here. The difference is now we've got a value here for a. So our a value is equal to 2. So this means a is greater than 1. So we'll see what happens. So our graph has moved this way. So it has been stretched vertically. So in this direction, this is vertically. So if we have a look at the next one, we've got y is equal to a half. So what happens when y is equal to a half? So this time, a is greater than 0, but it's less than 1. This is when a is equal to a half. So this time, our graph, don't know that one yet. So our graph is this one here. So this time it's been compressed vertically. Okay, so this here, the value, is coming down in this direction. So this one here, when it's negative. So A this time is, as we said, A is less than 1. But if we have A is minus, so A this time is equal to minus 1. So A is less than 1. We know it's going to be reflected in the x-axis. So if we have a look, so this value here has been reflected. So all our points have been reflected into the x-axis. So let's have a look at the domain and the range. So if we look at this graph here, so we have the domain, which is all the x values. So this is going to be all real numbers from negative infinity to positive infinity. So all real numbers. And we can also write it in this form. And if we look at the domain, the range for the y values. So the y values. So this time the asymptote. So we have an asymptote at y is equal to 0. So it's not going to reach 0. The values will not reach 0. So this time the values, y, is going to be anything that's less than 0, because it's negative.